Good afternoon, everybody. Hey, I have a absolute value equation for you, and it's a setup where we have two absolute value expressions on the left-hand side and a constant on the right-hand side. Now, frequently, these type of problems are broken into two separate cases since the absolute value is a piecewise definition. But this particular problem lends itself to another approach, and I want to get started on that. Now, what I did is I just went ahead and gave a name to the left-hand side to facilitate substitutions here. I called f of x equal to the absolute value of x plus 3 plus the absolute value of x minus 1. And that makes it easier just to substitute numbers in a more mathematic symbology sort of way. So notice that if you substitute 1 right here, f at 1, this piece right here becomes 0, the absolute value of 0. This piece right here becomes the absolute value of 4, and so you get 4. Now, so that's one solution, but it turns out there's another one when you substitute -3 in. And these are numbers you would naturally try because you're just checking to see, what's going on with the problem before you get in depth. So if you put -3 right here, this is 0. This is -3 minus 1, which is -4, and the absolute value of -4 is 4. So we already have two solutions, namely 1 and -3. And right here, it's awful tempting. You found two answers just like that. And so you might say, well, these are the answers. -3, 1 would be the solution set. But we know that most math problems aren't that easy. There's usually a little bit more to them, although some you can guess and test. It turns out this is not one of them. So we do know that -3 and 1 would be part of the solution set. Okay, now let's continue. Now, so we know that -3 and -1 is part of the solution set, but we're checking numbers near there. So we're gonna let A be a value contained in that interval -3, 1. Now, a key thing to notice here is that the length of this interval is a distance of 4. Okay, -3 to 1 has a length of 4, right? Three on the negative side and then 1 on the positive side. So that's a length of 4. Now remember the interpretation of absolute value. The absolute value is distance. So right here, the absolute value of a plus 3 is the distance from a to -3. Now that's a little confusing, but just think about -1, okay? If you put -1 in here, you know that -1 in advance is only 2 away from -3. But if you put -1 here, you get absolute value of 2 is 2. So this is the distance from a to -3. In a similar fashion, the absolute value of a minus 1 is the distance from a to 1. Now, so if a is anywhere in that segment or anywhere in that interval, it's going to break it up into two segments. And since the length is 2, the length of those two segments have to add up to 4. All right, so what we have shown is that for all a inside the interval -3, 1, we have a solution to our original equation. So that would mean this piece right here would be the solution set. It's not just the numbers -3 and 1 in a singleton fashion. It's the entire interval of numbers -3 to 1 close. Now let me see if I can use Zoom here to draw a quick picture of what's really going on right here. Let's see here. Okay, draw. Yeah, now, so what's really happening here, is this working? Yeah. This is the infamous Zoom, I guess, whiteboard. Now let's put 0 right here in the middle. Okay, 0. Okay, so y'all, this is just the number line with 0 in the middle. Now we'll put 1 right here. Count over 1 unit. This is 1. Okay, that's the I think my Wi-Fi is missing. Okay, so that's 1. Let's count -3, 1, 2, -3, right over here, right? That would be the location for -3, okay? Now, so folks, you can see real easy. Let's say we pick a number right here. We'll say 1/2. You don't even have to give it a -1/2. That would be -1/2, right? Okay. Well, the distance from -1/2 to -3 is just 2.5, right? Oh, come on. I pray this thing just works marginally. This is that whiteboard in Zoom that to impress with. Okay, folks, that distance there, I'm trying to do 2.5 right there, okay? So this distance from here to here is 2.5. There's my 2.5. I'm not going to try to change it. That's about as neat as it's going to get. Okay, again, the distance from this location right here, if you want to call it -1/2 to -3, is 2.5, right? And then the distance, this distance right here, I'm going to call that 3/2 because it's easier for me to write. Okay, that's the same as 1.5. I think we managed to get this, folks. If you can trust me on that, that's 2.5 or 5/2 right there. Make it a little easier. Okay, now, so you see, notice that 5/2 plus 3/2 is 8/2 is 4. Now, the same kind of thing would happen no matter where you pick your number. So A is just segmenting this interval that has a length of 4 into 2 subintervals, and the length of each interval has to add up to 4. So that's a proof by picture right there. But anyway, I hope you guys enjoyed that proof.